but due to some technical problems, Mumbai weather has been very weird. That day I did not have internet connection. That's why we did not have class on Monday. Okay. How was your space journey? Did I went to space? Did I go to space? You did not tell me that I went to space. Okay, so you didn't post anything. Actually, I remember that I did not post anything. Though I have videos, so I will be sharing it. Don't worry. Okay. So birthday party is coming. Who's throwing me a birthday party? Who's throwing me a birthday party? I know, yaar. बहुत बहुत आज तो weather is extremely weird in Mumbai. I'll throw my birthday party. Yes. Yeah. So you all are invited online. Yes. Just a teaser of that. So please tell me your secret address, because it is secret address. So you get to take a train for that from platform 3/4. Okay. Yes, 3/4. Some of you will get the reference, some of you might not. Absolutely. Cool. Great. Awesome. So everybody, yes, new chapter today. But before we begin, quickly say hello to your class teachers, Anil sir, Ranganath sir, and Anshul sir. Quickly, everybody say hi to your class teachers. Yes. Great. Sir will send us cake online on birthday. I'll show you the cakes here only. Okay. Great. Okay, everybody. Okay. I know there's a lot of questions coming in the chat box about tomorrow's class. I'm not responding to it because I want everybody to join the class. So I'll speak about that somewhere in the middle of the session. Okay. Is everyone okay? Okay. Vihan, solid mechanics and fluid mechanics are not interrelated. Okay. So this is a fresh start of the chapter. No problems with solid mechanics. Okay. So if you did not attend the previous class, that's absolutely okay. Okay. Yes, last chapter was a very small chapter, only one session. We have completed that. Yes, the smallest chapter of 11th standard physics. Shall we go forward? Sir, do you drink COMK? वो क्या होता है? What's COMK? Shimon sir's drink is COMK. Maths वाले लोग extraordinary चीजें करते हैं. We physics people don't get to do extraordinary things. Okay. Yep. Cool. With your permission, I would like to start the session, all of you. With your permission, with my folded hands, I would like to start the session, as always. Thank you. And if you have many more questions, which can just waste our time, please save them for the end of the session. Okay. Thank you. Okay. Switching off the chat so that I can finally focus on the screen. So everyone, today's chapter is fluid mechanics. And for those of you who are asking, sir, is it the last chapter of 11th standard? Absolutely not. Is it the last chapter of mechanics? Still, the answer is no. So there is still simple harmonic motion and waves. 2 more chapters in mechanics to be studied after this, but I think just after fluid mechanics, I'm not sure, but just after fluid mechanics, we will have sessions of thermal physics, that is thermodynamics. And then maybe we'll come back to SHM and waves. We'll end 11th standard syllabus on SHM and waves. Okay? Because the syllabus has been actually aligned with your CBSE term 1 and term 2. Okay? Okay, everybody. Class teachers, please do not forward me any doubts which are not related to this session right now. Okay? I will speak to everybody at the end of the class. Am I clear? Class teachers and students, please do not ask teachers the questions which you want to ask me. You can ask me at the end of the class. Okay? Thank you. Okay, everyone, so let's talk about fluid mechanics. So fluid mechanics is a lovely chapter, as the entire mechanics is. And as the name suggests, we'll be speaking about fluids and how their kinetic potential energy and the other mechanical quantities related to them make this chapter different from the other chapters that we have studied. Okay, so for the first time, we'll be speaking about things which are other than solids, because whatever we have studied so far, we have never spoken about anything which is fluid. Okay, so let's first set the agenda for the day. We'll be talking about the introductory part of fluids. What exactly is fluid? We'll speak about the most important quantity, which is pressure for the fluids. Then we'll speak about the difference between something called as atmospheric pressure, you might have heard about it, absolute pressure and gauge pressure. Okay, and finally we'll speak about a small topic called as horizontal force on the walls of a container. So maybe if there's a container on which the fluid inside it is filled, so how much force will be applied by the fluid pressure on the container walls. Okay, so let's start. So what exactly is a fluid? Most of us think that fluid is liquid. Okay, so first thing first, we'll set our understanding right. Fluid is not just liquids. Definitely liquids are fluids, but all fluids are not just liquids. Fluids are by definition anything which can flow. And we know that not only can liquids flow, your gases can also flow. So technically when we say fluids, fluids are liquids and gases. Okay, most of the fluids are a little bit of chemistry. That's not my domain though. Most of the liquids and gases are non-metals, except one, and that is something which I'm expecting everybody to know. Right? There's only one metal on Earth which remains in the liquid state, that is mercury. Okay, but still technically that's a fluid. That's for physics. So guys, we will be having our that's lightning by the way. So we'll be having our discussion related to fluids, but for our discussion purpose, we will be actually in this chapter speaking only about liquids. Then what happens to the gases, sir? For that, we will be having a separate discussion and actually a lengthy discussion in thermal physics. That means we'll be speaking about kinetic theory of gases, we'll be speaking about thermodynamics. So we will have a detailed, lengthy discussion about specifically gases in this chapter. Our discussion will actually be revolving more around the liquids, but the conditions, the things that we're going to study are equally valid for fluids also. Okay, so what kind of discussion that we're going to have about fluids? We will broadly, we will have 2 types of categorization in the chapter first of all. First thing would be to speak about fluids which are inside a container, and inside the container they are at rest. As always, our prop, liquid which is filled inside, is stationary. Okay, when you say stationary, it can do this, but it is not flowing basically. You know that fluids can flow, but if the fluid is not flowing, we call that branch of fluid mechanics to be fluid statics. Static means something which is not moving. So first part of the discussion will be about fluid statics. Second part of the discussion will be about fluid dynamics. That means when the fluid starts to flow. How do we study that? That's first categorization. a bigger categorization is to talk about ideal fluids, and then in the later half of our discussion, we'll speak about the real fluids. And real fluids discussion will be mostly revolving around the fluids which are in motion, that means fluid dynamics. Okay, so fluid statics, fluid dynamics, and also real fluids, ideal fluids. So we will be having our first round of discussion. In fact, 75% of the discussion of fluid mechanics is about the ideal fluids. Later on, we'll speak about real fluids. In that, we'll be discussing what is viscosity, something called as surface tension. We'll speak about these things. Okay, everybody? So yes, liquids and gases, they are fluids. We'll be having our discussion broadly divided into these two categories, fluid statics and fluid dynamics. I've already given you the definition, basic definition. Fluid statics is the branch which deals with the study of fluids which are at rest, okay, relative to the container, obviously. Container can move, but in our case, the fluids will remain stationary inside the container. Okay, when we speak about fluid dynamics, the container may not move, but fluid inside it will move. What type of container? Inside which the fluid can move? A pipe, maybe a river. In that, the thing which is containing the liquid is not moving, but the liquid is moving in it. That's the flow of the liquid. Okay? So obviously the discussion will start with fluid statics today. So when we speak about fluids, there are two very important terms that we need to understand. Out of that, one of them you already are very well versed with. Okay? The first one, the two important properties which are related to fluids. The first one is density, and the second one is pressure. Though now we know that we can define density as linear mass density, surface mass density, and volume density, but because fluids are not 1D or 2D, they're always 3D things. So we will be considering the usual understanding of density as mass upon volume. Okay, everyone. So let's start with slow and steady. What is density? It is simply how much matter is packed in a given volume. So if I imaginarily take 1 centimeter cube, now what is 1 centimeter cube? The dice that we use in the game of Ludo or Snakes and Ladder, or maybe Rubik's Cube, you must have seen one of the cube of that. That's 1 centimeter cube. Okay, how much amount of mass inside it is being filled or packed? That mass divided by the 1 centimeter cube volume or mass per unit volume is what we define as the density. So definitely, if I have a liquid like water filled in that 1 centimeter cube and will try to lift it, it will feel very lighter. Comparative to that, if you will fill inside that in the powder form, say iron you fill inside, definitely it will be much heavier. And if you fill mercury inside it, much more heavier. Okay, so we'll speak about the density of mercury also very soon. We know that density defined as mass upon volume is a scalar quantity, and units also something that we are aware about, kg per meter cube. And density, I'm sure that you guys know the dimensions also, m1, l minus 3. I'm sure there is no doubt about density. Okay, everyone. But the discussion has to move forward from there, where we speak about something called as relative density. Okay, now what is relative density? Relative density is basically the ratio of density of one substance with respect to another one. That means what? Say there is a reference material with respect to which you are comparing how dense the other materials are. So the reference material is in the denominator, the density, and in the numerator you have the density of the substance which you want to actually compare with. So maybe your reference becomes mercury. So with respect to mercury, if you compare water, if you compare say air, if you compare iron, if you compare oil, different values of relative densities of those will come. That will mean you are trying to compare their densities with mercury. Okay. Obviously, as you can see by the formula also, that relative density is a ratio. So definitely it's unitless, it's dimensionless. Okay. I hope everybody gets this. Why are we defining it is for the thing that we are going to see in a few more minutes. Okay. So we have understood relative density is density of a substance divided by the density of a reference substance. So say for example, I want to talk about the relative density of mercury with respect to water. Means in comparison to water, how dense mercury is. So general trivial point of view, trivial means common sense, not just common sense, from general knowledge point of view, please, if you can, keep the value of density of mercury in mind. It's 13.6 into 1000 kg per meter cube, and most likely how it is, how usually it is memorized by people is 13.6 gram per cc, or that means gram per centimeter cube. So it's easier to remember 13.6 gram per centimeter cube, but remember it is easiest unit, gram per centimeter cube. If you want to use it in SI unit, 13.6 multiplied by 1000 has to be done. You know how to do the unit conversion. Also, the density of water is 1000 kg per meter cube, or 1 gram per centimeter cube, or gram per cc. That's for water. Okay, these two are usually the values of densities which I recommend you to remember. Though in an exam like JEE, they will definitely give you whenever required, but it's not going to hurt you if you remember. Okay, guys. So if you calculate the relative density, you can directly see it from here only. Just divide 13.6 by 1. They are the same units, so answer is going to be 13.6 only. Right, everyone? So this is the relative density of mercury with respect to water. Okay, I hope everyone gets this. Okay, now why we have defined the relative density is because we want to define another term similar to that, which we call as specific gravity. Okay, and what is specific gravity? It is actually a fancy name given to the relative density only. Specifically, if you are taking relative density of a material, of a substance with respect to water, that means in the denominator of this formula. In the denominator of this formula, if the density of the reference substance which you are writing is that reference material water, if that reference substance is water, then this relative density will be given a special name. That's it, fancy name, nothing else, and that will be called as specific gravity. Let's read it once. It says that when the reference substance is water, the relative density is also known as the specific gravity of that substance. Okay, everyone. So we can say that what we got as the expression in the previous slide, 13.6, as the relative density of mercury, can also be called to be the specific gravity of mercury. Okay, so that's what is written here. That the specific gravity of mercury is 13.6 means what? If ever in a question they give you the specific gravity of something, so it is your duty to remember that specific gravity is nothing but relative density where the reference material, reference substance is water. Okay, everyone, you can take a note of it also. Okay, cool. Hope it is clear to everybody. Okay, nice. Okay, guys, so quickly try to answer this question for me. Question number 1 for today. It says that a wooden block of mass m floats on water. We all know that. Okay, but a steel needle, maybe of the same mass, it will sink. Means what? Same mass. One is wood, the other one is iron needle. The wooden block floats, the iron needle sinks. What do you think probably is the reason behind it? Think about it and try to answer it. Giving you 45 seconds, and your time starts in 3, 2, and 1. Last 5 seconds now. Okay, and the time is up. Let's see. It's not a very hard one to guess. As expected, very good. Yes, so the entire game is of density. So you can take a guess also. If the reference material is water, okay, and say you are putting wood, you are putting iron of same mass. Because iron's density is more than water, it's going to sink. On the other hand, if the density of wood is lesser, which is usually the case, it's not going to sink. It's going to float. Okay. So the idea is the material, its relative density has to be less than 1. If you're talking, or rather, its specific gravity has to be less than 1. Because if the density of the material is less than water, then the specific gravity value will definitely come out to be less than 1. If that happens, the material floats. And if that relative density or specific gravity comes out to be more than 1, the material is bound to sink. Okay, we will have a more analytical or mathematical discussion on this, not today, but in the next session, where we'll speak about the Eureka story. You all must have heard about the Eureka story, right? Archimedes principles. We'll speak about that. Not today, but in the next session. Okay, guys. So density of wood is lesser than water, and density of needle is more than water. That's why it is going to sink. Okay, everyone is good with this. Nice. Okay, people. So now, as I'm hoping that those who wanted to join the session today have joined, let me clear some air. So important announcement about tomorrow. Okay. Okay. Important announcement for tomorrow. What is that important announcement? You guys know that on Monday, unfortunately, we could not have our session, so we have to definitely keep the session going. We have to be in sync with our syllabus. So that's why tomorrow at 3 p.m. Okay, we will have our physics session. Obviously, fluid mechanics. Fluid mechanics part 2 or session number 2. No debate on that. This is what it is. Tomorrow, 3 o'clock is the only slot which was available. So we have placed it. We cannot just keep on postponing this. So that's why we have to place it tomorrow itself. Okay, everybody. Okay, Ganesh. Or Baki Janta. Chat be on it. The chat is also on. Let me ask you one thing. How many times have I placed my lecture at 3 o'clock? You tell me. How many times have I placed my lecture at 3 o'clock before? So do you understand that there is a reason why we are placing it at 3 o'clock? Okay. Are you guys available at 5:30 tomorrow? Are you guys available at 5:30 tomorrow? You guys do not have a session at 5:30 tomorrow? You guys don't have a session at... You don't have? No session at 5:30 tomorrow. Pakka. Wait a minute. Do you have a 5:30 session tomorrow? Click on the hotspot. No, if you guys do not have a 5:30 slot tomorrow filled, then I will be moving it to 5:30. Okay, everyone? Okay, ending it at 3, 2, and 1. ये 15% लोग कौन है? Who are these 15% people? You do realize which session I'm trying to place here. Asha, let's do one thing. Though I should not be doing this poll, but I am a very democratic person. I believe in democracy. तो अभी इसको simplify कर लेते हैं. Just click on your preferred time slot. Okay. The option is always there. If you don't want to attend the lecture, you can always skip. If it turns out to be a tie or a close call, then the call will be mine. I have the veto power. I do believe in the democracy, but I have the veto power also. The body, the material, if it has specific gravity less than 1, will float. Gaurav Joshi. Last 5 seconds. And this is a close call. I will be taking the call then. Okay. Yes. So no discussion, no further discussion. Okay, everyone? No further discussion. Channel पे कोई मैसेज नहीं आएगा. It is final. Okay. I told you, it's not about majority or minority. Okay, everybody. Yes. So as you know that I do not usually move my sessions to this time slots, but special circumstances, right, everyone? ठीक है. चलो चैट बॉक्स पे लिखो जल्दी से. एक दिन अगर तुम 2 घंटे पहले सेशन अटेंड कर लोगे तो तुम्हारी फिजिक्स खराब नहीं हो जाएगी. You guys will not become all of a sudden art student or commerce student. Okay. Okay. अरे यार ये कौन है? ये लोग कौन है? एक मिनट. अरे 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 रुको, लिखना बंद करो जरा. ये कौन है ये लोग? कौन है ये लोग? हाँ? This is not a preponement of a session which will happen on Monday. This is the cover up of the session which did not happen on last Monday or day before yesterday. Okay. I'm not cancelling any lecture of coming Monday. Okay. For your information, 11th of October you will have your usual session. ठीक है? Daksh Chaudhary. Okay. Switching off the chat because you guys are just taking it to some other direction. Class teacher, can you please forward that message once again to me? Class teachers, some of you, one of you has forwarded one message to me. Can you please re-forward that to me quickly? Class teachers. Anil sir, Rangnath sir, Anshul sir, one of you just forwarded one message from a student. Can you please re-forward that to me quickly? Okay, fine, thank you. Okay, everyone, so this is final. You can actually, if you can, attend the session live with me. I'll be very grateful to all of you. Okay, and if you would not be able to attend this particular session live tomorrow, I humbly request you to watch the replay of this one, not this one. The session will happen tomorrow. Okay, everyone. So guys, taking it forward from here, let's not get into further haywire discussion on this. Okay. If you have more questions, you can ask your class teachers also. And Anshul sir, I expect you to answer that question, the one that you have forwarded to me. Okay. So everyone, let's talk about the second quantity, and that is pressure. Okay. So pressure is a very important quantity. This holds a huge importance in this entire chapter, in this entire unit of fluid mechanics. We have a little bit of idea about pressure as far as the formula is concerned. We are very well aware about it. Okay. But what we usually are not aware about is that what results in pressure. Why pressure happens? Why pressure is created by a fluid? So first of all, let's read what is written here. It says that when the fluid is at rest, it exerts a force perpendicular to any surface which is in contact with it, such as the wall of the container in which it is kept or the body immersed in it. That means what? The first diagram, if you have a look at it. This is maybe a glass, maybe a container inside which the fluid is filled. Because of the fluid pressure, the liquid will try to push. Every time liquid will try to push the container walls or anything which is solid which is surrounding it. So if the liquid is filled inside the bottle, the liquid right now is pushing from all the possible container walls wherever it is in contact. Obviously, it has to be in contact. And that is why you know that if this would be a plastic bottle and if I just puncture it, if I will put a hole inside it, because of that only the liquid will start coming out, because it tries to always escape by applying that force. Okay. And say if your fluid is having a solid body inside it, then also that's another surface. So apart from this situation, the fluid will also try to exert pressure and resulting in a force on that solid body which is filled inside. Means what? Say if you know how to swim, you would definitely know about what I'm speaking here. If you take a deep dive in water and you're not putting any earplugs, you will start feeling the pressure in your ears. You will actually be feeling a lot of pressure on your body also, on your skin also. That is because liquid tries to apply the force on every solid surface which comes in contact with it. Okay. This is something which I'm sure most of us might be already aware about. Actually, the bigger question is, why does even fluid tries to apply pressure? Think about the situation. If I will create any hole in this bottle, the liquid will try to escape and will always try to fall downwards. That simply means what? Because liquid has mass, it is also made up of molecules and atoms, so definitely it has matter and mass, so gravity is one of the things which is acting on it. Right? Means if I take this bottle, listen to me carefully, if I take this bottle which is filled with water in space, okay, or if we are in space and there is no gravity or very less gravity, and then you try to puncture the bottle, or in fact you just empty the bottle. What do you guys think? The liquid will still start to flow down in the space. It will rather try to float wherever it is. You might have seen some videos also. The liquid will try to just float wherever it is. You must have seen some astronaut videos maybe on any of the YouTube videos. Maybe you can do that. So this is where the story of pressure comes into picture. That why would and when would a liquid try to create a pressure? First of all, when we mathematically define pressure, we define it to be the force which it applies divided by the area, or force experienced per unit area, right? What exactly is this force is the most important part of it. In most of the situations that we will be discussing, it is actually the gravitational force which is acting on the fluid, which is trying to bring the fluid downward, because of which what is happening right now, you know that more pressure will be experienced by something which is here comparative to something which is here, comparative to something which is here. Or let me put it this way. If there is somebody who takes a sea dive, or say snorkeling, okay, if you do that snorkeling or any sea diving, can I say that the more deeper you go, the more is the pressure that you will be experiencing? Right, everyone? Why is that so? Is the answer that we are going to find out today. The reason is going to be gravity. The reason is going to be gravity. If there will be no gravity, the liquid will not create the pressure which we experience. Okay, we will be speaking about that in some time. Okay, everybody. So yes, what is pressure? Pressure is basically the normal force per unit area. Obviously, the liquid is trying to create or try to apply the force on all the possible surfaces where it is in contact with. If your liquid is in contact with multiple surfaces, on each and every surface it will try to apply force, but perpendicular to that surface. Like in this diagram, have a look. It is trying to apply this force which is perpendicular. It is trying to apply the force every point where it is applying it perpendicularly. Remember, the force that the liquid will try to apply will be perpendicular to the surface of that solid body. So it is normal force. That means perpendicular force per unit area. Very, very, very important. Remember, pressure is not a vector quantity. It is a scalar quantity. Why? Because it does not obey the laws of vector addition or the vector algebra. Okay, unit is something that I'm sure you are aware about. Newton per meter square, or after the scientist who gave us Pascal's law, the unit Newton per meter square as a respect is also called Pascal. The dimensions are also something that you always can find out. It's m1, l minus 1, t minus 2. Okay, everyone must be aware about these things very easily. Okay, people, cool. So in some time, I'll be telling you how, as we go deeper and deeper and deeper and deeper and deeper in the liquid, the value of the pressure increases and increases and increases. Why that happens, I'll tell you after a few more slides. Okay, so guys, the general idea of pressure inside the liquid will exert pressure due to vibration of the particles in the bulk, and it varies with the depth. It varies with the depth. This is something that I've already spoken about. And as your liquid molecules, they are more freely movable, especially the gas molecules, they're more freely movable. So when they strike, where exactly they basically apply the force for? You know that fluid molecules are more mobile. Gas molecules are even more mobile. So they keep on hitting the container walls. Wherever the liquid is in contact with the wall, it's continuously hitting it. Continuously the molecules are hitting it. And if they're continuously hitting it, they're definitely applying a force, because there will be collisions happening, and in collision there is momentum change, and whenever there is a momentum change, rate of change of momentum per unit time from laws of motion is basically the force. That force per unit area applied on the container wall is what we call as the pressure. Specifically for gases, we will derive the expression of pressure also. Yes, because of the gases. You might have studied something like that in chemistry, kinetic theory of gases if it is done. If it is not done, no problem. In physics, we will be deriving the expression of pressure which is exerted by the gases because of this particular reason which is mentioned here, because of the particles which are in bulk and they are continuously vibrating and hitting the container walls. Okay, so everyone, particles of gases are more free to move. They will hit the wall container with high velocity. That's why their momentums will change, and hence the pressure because of the force applied. Okay, I hope the preliminary feel of pressure has come. We are yet to explore this part, which we will be after a few questions that you will answer. Okay, so guys, a few questions for all of you guys to answer quickly. This one is a very simple one. The area of the wall of a dam or a gate is 20 meters square, and the normal force acting on it is 1500 newtons. Okay, it is applied by the liquid, this is water. So calculate the pressure applied by water on the wall, and this is the average pressure, obviously, that we are trying to calculate here. So 45 seconds, pressure, the formula I'm expecting everyone to now know, and time for 45 seconds starts in 3, 2, and 1. Last 10 seconds. Good. As expected, we know that the pressure is going to be force upon area. So this is what we call as free K marks. Don't have to do anything, just calculate this. Comes out to be 75 Newton per meter square. Okay, everyone. Next one. Conceptual question. Why do you think that the camel can easily walk in the desert, but we cannot walk as easily as they can? Because the camel is heavier in weight, because he has larger surface area of the feet. When they're saying he, it's basically camel. Okay, I'm sorry that they are being gender biased. They are calling it he. So it's because the camel is heavier in weight. It's because the camel has larger surface area of the feet. Both or none of these. Giving you guys 30 seconds, and the time starts in 3, 2, and 1. That's good. Nice. Okay, guys. So see, the option 1 is more contradicting. So option A should not have been the answer of anyone. Something which is heavier will be even difficult for that to move, right? But I'll give you a much better explanation of it. The answer is the larger surface area of the feet. I'll give you multiple explanations of it. Okay. The first one, on the sand, if you try to stand, forget about walking. If you try to stand, and comparative to that, if you try to lie down, where do you think your body will actually sink more? In situation 1 or situation 2? Where do you think your body will sink more? Speak from your experience, at least. Right? When you're standing, your feet actually will go down. They will actually be sinking inside. Can I say in both the cases your weight is same? Your weight obviously is not changing, right? So both cases, the value of mg is same. That means the force is same in both the cases. But look at the pressure. In the first one, it's area A1, that is P1. And in the second one, it is mg by area A2. Where do you think you have increased your surface area, which is in contact? In the second one. So denominator increased, hence pressure will decrease, right? That's one explanation. Okay. Second one, have you ever tried to put a nail in the wall? Have you guys ever tried to put a nail inside a wall by hammering? You must have, right? Have you ever tried to keep the nail in situation 2? Have you ever tried to be the Sheikh Chilli and do the opposite of what usually is expected? Okay, if you will try to do this, if you will try to actually try to hammer it from this side, if you try to hammer it in situation 2, you are actually increasing the area which is in contact with the wall. And because of that, the pressure which will be delivered to the wall will be less, even with the same force. That is why the nail will actually not go inside in situation number 2. Okay. Third one, if you have to, hold your travel suitcase, we all travel, right? So we used to travel, say at least before COVID times, we all used to travel. So when we travel, imagine the suitcase which is like heavily loaded with your stuff and does not have that grip which is at least this much wide. Okay, it has like at least 1 inch or 2 inch width, or maybe your school bag, the strap. If that strap suddenly becomes only this thin, the strap, you will have like bruises here. It will pain a lot here. Why? Because surface area will reduce, pressure will increase for the same weight of the bag. Is the situation understood by everyone? Understood, right? Perfect. So this is the story of the pressure. Okay, so that is what happens. So design of the feet of camel is such that they have larger feet area compared to us. So even when they are heavier, their weight actually get distributed. Because of that, they apply lesser pressure, even when they have more weight compared to us. Okay, so just the thing that you guys were waiting for, and that is how when we go deeper and deeper in water, maybe in swimming pool, maybe anywhere in, you might have done sea diving or anything, snorkeling. As we go further down and down and down, we feel the pressure in our ears and on our body also. Why that happens? Because the pressure will increase with the depth. Okay, so let's speak about the fluid pressure at a depth h inside. So as I said, that fluid is not like dying to create a pressure on anything which it isn't coming in contact with. Rather, it wants to apply the pressure because of the external force which is acting on the liquid itself or fluid itself. Means what? Fluid also is experiencing a force, that is gravity. It is trying to pull it downward. But what happens? This container has this surface which is not letting the liquid fall down. So definitely the liquid is trying to exert a force downward. That force is creating the pressure. Okay. Before we even do the derivation that we are about to see, and you already are aware about the formula also, by the way, the pressure formula. Let me tell you a few very important qualities of the pressure, few important properties of the pressure. First, very important property. I will, try to write this in a separate sheet. So if you have fluid filled in a container, okay, there are certain properties that your fluid will always obey. The first thing is, if you look at these different layers, each and every point on a given layer, say A, B, and C, in a given layer, the pressure will always remain the same, even when it is in contact with the container. All the points which are belonging to the same layer of the fluid will have the same pressure. Okay, points of same layer have same pressure. Okay, we'll prove it also in some time once the expression also comes down. Second one, fluid pressure is independent of shape of the container. If you have two containers and they both have fluids which are filled to the same height, okay, one of them may be having a shape which is cylindrical, the other may be a conical one, the other one may be like a bottle which is having a very artistic shape. But as long as the fluid level, when I say level, as long as they have the same height of the fluid filled to them, the pressure at a given depth will always be same, irrespective of the shape of the container, also irrespective of the amount of fluid which is filled. It just have to be of the same height. Okay, I'll draw that also separately for all of you here. So say maybe you have one container like this, and the other one is like this. The other one is say like this. Pardon my beautiful drawing. Okay, very difficult, just like making curly brackets. So if you have fluid filled in them up to same height, do you guys hear that? Scary. So go farther from window to right. I'm not on the top floor. Okay, everyone switching off the chat so that we can focus here. Remember, as long as you have the same height, okay, the pressure at any given point at the same height or same depth will always be same. Okay, so maybe if this is A, this is B, this is C, and this is D, they actually belong to the same layer also technically, or they are actually at the same depth. So we can say pressure at A, pressure at B equal to pressure at C equal to pressure at D. I'm just re-explaining this point there. Okay, cool. So please keep this point in mind because this is what will help us talk about this. So now coming to the real discussion, that is about fluid pressure. So everyone, say I'll start finding the expression of fluid pressure at the bottom of the container. Okay, so at the bottom of the container, if I want to pick any point which is here, let's call that point to be X. Okay, and I want to find out the pressure at X. Can I say that technically the entire fluid mass is above it? The entire fluid mass is above it, right? Means if you think of this fluid to be like a box of the same mass of the liquid, and at X maybe you are standing and this entire box is placed above your head. So even if not the entire box is in contact with your head, you will still feel the pressure of the entire weight. Do you guys agree? Imagine you are standing at point X and a box, heavy box is above you. Not the entire box is in contact with your head, right? But still you feel the pressure of the entire, like a pulley, right? Yes. Understood? So that point X is actually going to feel the pressure due to the entire weight of the fluid. Getting it, everyone? So can I say that this force upon area that I'm trying to write down is nothing but mg by A? What is mg? Weight of liquid, or I should say fluid, above point X. This last line is very important. Okay, this has to be the point which is above X. Means what? Say you are standing here and you have a heavy box of mass m above you, or maybe just small m mass, but you are standing on another block whose mass is capital M. Tell me in the chat box, will you feel any pressure because of capital M mass? Will your head feel any pressure because of your mass below you? Right, everyone? Getting it? Understood? Yes. So everybody, let's try to write down mg for the liquid or the fluid divided by the area of CS. CS means area of cross section. Cross section is basically the cylinder portion here. So that's basically the area of cross section. Okay. So everybody, let's try to do this derivation completed. It's a very simple one. I can write the mass of the liquid as its density into volume into G divided by A. So this is mass. And I'm going to replace this volume term as area into height. That's basically the area of any body. In this case, it is area of cross section multiplied by the height to which the liquid is filled. It is not the height of the container, it is height to which liquid is filled. Okay. So rho into A into H into G divided by A. You see that here A got cancelled, and final expression of the pressure comes out to be rho GH or H rho into G. What is rho? Rho is the density of the fluid. H is the height to which you are talking about, the height above point X. I should not say height to which liquid is filled. I should say whichever point you are interested in finding the pressure, the height of the liquid column above that point. Okay, and G is acceleration due to gravity. How I'm trying to make it even more clearer to all of you, let me just do this part also. So say you have fluid which is filled in a container. Okay, I'll make a smaller container. This one is a much bigger one. Okay, and it has fluid which is filled. Okay, so let's talk about two different heights. Maybe this is height H1. There comes a layer L1, and then there is height H2, so that you talk about layer L2. Okay, everyone. So if I speak about any point here, let's call that point X, and any point here, let's call that point Y. So the pressure at X will be in the chat box X into rho G, H1 into rho G, or H2 into rho G. Will be H1 into rho G or H2 into rho G, or will it be same for both? It will be only H1 into rho into G. Yes, and pressure at Y will be H2 into rho into G. So remember, it is not height of the liquid column. It is not that the liquid has been filled to a height 10 centimeter, so every point will have the same pressure. No, you need to define which point you are finding the pressure at, and from the surface of the fluid, go to that point. What is the liquid column? H is called the height of the liquid column above that point. Okay, everyone? Height of liquid column above the concerned point. X, Y, etc. Fine? Cool. But so far, when we were speaking about the liquid pressure, the container was covered. The container surface on the top was covered. It is covered. What if I open it up? Will there be any additional pressure that will come inside? Should there be? Awesome. Yes. You know that we are surrounded by the atmosphere. We are surrounded by the atmospheric gases. And if we open the surface to atmosphere, notice the difference here. This was covered, and now we are opening it to atmosphere. So at the same point here, now the pressure will be the same H rho G, but it will also have an additional pressure which is getting equally distributed. Okay. So this is very important to remember when you're going to solve questions, whether the liquid is covered or it has atmospheric pressure also present in it. Okay, everyone is clear with this? We'll have more discussion about atmospheric pressure in coming few slides. Let's have a look at an example quickly. Okay, we have to assume the miniature points as the concerned points as miniature coolies. You can, nobody's stopping you. Okay guys, so the density of sea water is given to us in this example. the maximum depth of the Atlantic Ocean is 8,500 meters or 8.5 kilometers. Calculate the water pressure at the depth. So basically, application of formula. We just have to apply the same formula that we have just now learned. I'm not getting into the calculations. It is more of just remembering how to apply this formula. Okay. So only the water pressure has been asked, not the overall pressure. Okay. So we will just calculate H rho g. We will not add atmospheric pressure. We do not even yet officially we do not know in this class what exactly is atmospheric pressure. Its value. So we will find that out. As of now, the liquid pressure, the water pressure is H rho g. Height, obviously, we'll put in SI unit, 8,500 meters. The density of seawater is 1025, little more than the pure water density because of the impurities mixed in it maybe. And G value taking officially 9.8. I don't like to do that, but okay. Looking at the options, they can be taken to be 10 also. You can take this value as 10 as well. So when you will solve this, I don't know why would you do this calculation. If you have to, you can always use maybe log table or maybe skip the question. But yes, if you ever have to, you will take the value of G as 10 and find the value. It will come out to be close to 8.5 into 10 to the power 4 kilopascal. So kilopascal. Just a second. 8.5. 10 to the power 4. 8.54 into 10 to the power 4 kilopascal. Why? Because this is 8.54 into 10 to the power 7 pascal. So they want to actually write in kilopascal. That's why 10 to the power 4 is separate, 10 to the power 3 is separate. Like this. So this part has been written as kilopascal. Okay, guys? Sure. One question for you guys to try. Let's see if you can try this. Now you have a better understanding of the pressure. A submarine experiences a pressure of 5.5 into 10 to the power 6. Submarine is basically kind of a water ship which goes underneath water. Submarine, I'm sure you might have heard about, right? So it experiences a pressure of 5.05 into 10 to the power 6 pascal when it is at a depth d1. Okay, so inside the sea water, maybe when the submarine is somewhere here, okay, it is at a depth d1, so it experiences the pressure p1. Now when it goes further to a depth of d2, that means it goes further down. Okay, the pressure becomes p2. No comments whether p1 is more or p2 is more. Question is saying what, and the pressure if at d2 becomes 8.08 into 10 to the power 6. It's quite visible. Sorry, it's quite visible that pressure p2 is more. So question is asking us the value of d2 minus d1 will be approximately how much of the value of density of water is given, value of small g is given. Let me see if atmospheric pressure is used or not. Okay, so assume that atmospheric pressure is neglected in this case. Okay, though it will not create any difference though, but still for your preliminary understanding, say that atmospheric pressure can be neglected. So everyone, you have to find out the value of d2 minus d1. How much do you think that's going to be? I'm going to give you guys 90 seconds for this, and your time starts in 3, 2, and 1. Come on, everyone. Half time is gone. Last 15 seconds coming. All of you. Okay, and the time is up. My God, nobody got this. Only close to 3% people got this. Can I say that P1 is going to be D1 into rho into G, and that value is 5.05 into 10 to the power 6. Let me see if there's a blunder in the question or not. I'm hoping rather, it should not be. And P2 will be D2 into rho into G, and that's given to us as 8.08 into 10 to the power 6. So even if you add P atmosphere, that's fine, you can add, because eventually you are going to subtract these two. P2 minus P1, if you subtract these, comes out to be 3.03 into 10 to the power 6, and that value is D2 minus D1 into rho into G. Right, everyone? So D2 minus D1 is going to be close to 3 into 10 to the power 6 divided by density of water, that is 10 to the power 3. G value I'm taking it as 10. So 10 to the power 4 goes up. This value is nearly equal to 300 meters. Do you guys get it? Easy? Was there a wrong tag? Was it wrongly tagged? Oh yes, it was tagged as answer as option D. Let's just give it a thumbs down. Okay. Answer is option A. Correct? Even I was surprised actually. So I have given my feedback. Please share your feedback. Okay. Error in the previous question. kg per meter cube. I think you're talking about this one. Density. This one will be kg per meter cube. ठीक है. ये तो छोटी सी बात है. ये वाला हम समझ सकते हैं ना. This is something that we all understand. It's kg per meter cube. Cool, everyone. So yes, what is important is to see that the answer comes out to be close to 300. Okay, everybody. Let's move on and speak about the second part of the today's discussion, and that is about atmospheric pressure. Understanding the difference between what is atmospheric pressure, what is absolute pressure, what is gauge pressure. Okay, they are just interrelated to each other, and we have to just get a clear understanding of these three. Okay, first of all, tell me in the chat box, have you guys ever heard about something called as a barometer? Have you guys heard about a barometer before? Have you guys? Tell me in the chat box. You have. That's good. What does it do? Have you guys heard about barometer? If you have, then what does it do? It is used to measure. It is used to measure atmospheric pressure. Which liquid is used in barometer? Which liquid is used in barometer? Mercury. Yes. Any other liquid can be used or cannot be used at all? Any other liquid can be used or cannot be used? Cannot be used. Okay, so we will find out. Can be used or not. Okay. Yes. So everyone, let's first understand what exactly it is. Just a quick view of this slide, and especially point number 1. Point of same layers, okay, points of same layer will have the same pressure. This single line is the concept of barometer. This single line is the concept of barometer. Okay, so everyone, there is one experiment which if you have not conducted in your life so far, you will conduct it because it is a home experiment that you can do. What is that experiment? In a very broad pan or broad container, usually in which the dough is made in the kitchen, हिंदी बोलने वाले लोगों के लिए घर में जिसमें आटा लगाया जाता है, उस वाले बर्तन में, okay, in that container, fill water in it. Okay, after filling water, put a candle over there, but not a very tall candle. Put a small candle, which can actually be above the water level also. Okay, good enough above water level. Okay, yes, light the candle. Listen to the steps. Huh? Take the container, fill with water, put the candle, and light it up. And then do what? Take a glass tumbler, a glass which you can see, not the steel glass. Please don't take steel glass. Okay, take the one which is made up of glass. Yeah, and cover the candle. After some time, the candle will stop burning because of the lack of oxygen. And the moment it is going to stop burning, the water level will rise up. The water level will rise up. Okay. Similar is the situation with the barometer. Okay. Yes, vacuum gets created at the top, or you can say the composition of the gases above the candle wall or in the candle wall situation in the container, the tumbler, is different in comparison to what is outside. And this is what is the situation of a barometer also. So what is a barometer? We'll come to that in some time. But right now, what is atmospheric pressure is something which I'm expecting all of you to understand. Okay. So the pressure of the atmospheric gases, which is applied uniformly on all the surfaces, is basically what we call as the atmospheric pressure, and the concept is exactly the same. The weight of the atmospheric gases are also experiencing gravitational force. So Earth is trying to pull them. So whichever object comes in between, okay, say you and me also become in between. So the atmospheric gases are not able to every time collide, or all of them are not simultaneously able to come in contact with Earth's surface. So they basically create pressure on our body, pressure on this bottle, pressure on anything which comes. Okay, everyone. Have you guys ever wondered that when the astronauts go in space, especially in space outside the spacecraft, they have to wear a suit? They have to wear a suit. Why? Just because it looks fancy? Just because it looks fancy? No, not that. The reason is right now, the atmospheric pressure. Okay, you might have also heard about this before I explain this. Many people, when they travel to higher altitudes, they have breathing problem. But more than that, many people bleed from nose. Many people start bleeding from nose when they go to higher altitudes. Nose bleeding happens. This is basically because of the blood pressure that we have. It is our body is so well designed that the atmospheric pressure from outside and the blood pressure from inside has a equilibrium, has a balance, because of which we don't require any special suit. But imagine an astronaut going out in space. An astronaut going out in space does not have that atmosphere, so they have to have that suit which will create that atmospheric pressure in them. Is the logic clear? Right, everyone? Cool, awesome. So exactly that's the situation. You can see that this is shown as height h1, this is shown as height h2. So usually atmospheric pressure that we take into account, we use, is taken above the sea level. So at sea level, the value which you see here is the one which we'll be using also. Okay, and 99% of the time we will directly be using it just as 10 to the power 4 or 10 to the power 5 Pascal, or in CGS unit we'll just call it 1 atmosphere. CGS unit is 1 atmosphere. Okay, so instead of writing it as 1.01 into 10 to the power 5, we can say it is nearly equal to 10 to the power 5 Pascals, unless we see that it is better to take 1.01. Okay, please take a note of this value. I'm sure you have some idea about this value from chemistry also. Okay, everybody, so let's move on. Let's go to this one, the quiz. Let's see if you can answer this. What will happen what will happen with a bottle if we suck all the air out of it? So say take a vacuum cleaner and put it on the mouth of the bottle, a Pepsi or a Coke bottle, which is already empty. You've already consumed the entire cold drink, and then you suck out all the air which is inside. What will happen to it? It will expand further. It will collapse. No change, or none of these. Give me only 15 seconds, and the time starts in 3, 2, and 1. Good, nice. Okay, so what will happen? Inside will be vacuum, outside will be atmospheric gases creating the pressure, so the bottle will collapse. That's what happens. Okay, now comes the barometer. So this was basically a device which was developed by an Italian scientist, Evangelista Torricelli. Okay. As weird, the foreigners or abroad people find our name, similar weirdness is there with many European names, such as the name of Torricelli. And just look at the year, 1607. Where was India then? I do not know, but definitely Italy was doing good, Europe was doing good, so they had already barometer kind of devices being developed. So what does it use is something that we already know. And my patriotic friends, please don't get offended. India has also been the country, or it used to be called as golden bird, right? So don't take it as that I don't like my country. I do love my country. Okay. Please don't write an email to the government of India. Okay. Please do not write an email to the government of India. Otherwise, you will be taught by some other physics teacher very soon. Yes. Chalo, oh yeah. So everyone, the experiment that I was talking about, which you can conduct at your home, is basically this one. So what you basically see here exactly is the situation which is there, which is with vacuum. So there's a container over which there is a test tube maybe, or a glass tumbler, and you have to make sure there is vacuum over it. Because if it will not be a vacuum, it will be still the same atmospheric gases. Then this mercury column will not lift up. Okay, everyone. So this is what happens when you create a barometer. Barometer is basically an arrangement. It's not an extraordinary device. It is an arrangement in which you have to have your space for the liquid to rise, and it rises by itself the moment you have on the top of it the vacuum. The candle was basically trying to do that. The moment it stops burning, in the composition of the air, oxygen goes down, carbon dioxide goes up. So whatever is the composition of the atmospheric gases outside the tumbler is no more the same composition which was inside it. So more or less a vacuum kind of situation happens, and the liquid has to rise up in order to make sure that pressure balancing happens. Now again, reminding you people about the point that all the points which belong to the same layer have the same pressure. Remember that point. So everybody, the side view of the same situation, and please pay attention to this one. This is very important in terms of understanding. Okay, there's nothing new which you are going to find out as the result, but how the barometer works depends on this. So you see that point 1 and point 2 technically they belong to the same layer. They belong to the same layer. So if they belong to the same layer, pressure at point 1 should be equal to pressure at point 2. But at point 1, it is atmospheric gases which are creating the pressure. But at point 2, here is nothing which is going to create an atmospheric pressure. So to have the same amount of pressure, something has to go up to create the same amount of pressure. And that is being done by the mercury column here. This mercury column of height h has to have the same amount of pressure to be able to equate the value of pressure at point 1. Are you guys getting the logic that why the mercury column has to get created, why the liquid has to rise inside it, so that it can create the same amount of pressure at point 2, so that it can also be equal to point 1 pressure, right everyone? So this is P atmosphere, and this is going to be h into rho into g. Now what is rho? Rho is the density of mercury. Which curry? Mercury, okay, 13.6 gram per cc. Yes. So experimentally it is found that the value of h comes out to be 760 millimeters of Hg column, or 76 centimeter of mercury column. What is written here also? It is found that in the test tube, the mercury will rise up by 76 centimeters. Remember, at times in the questions, they give you the value of atmospheric pressure just by saying 76 centimeter of mercury column. That is equivalent of the atmospheric pressure. Okay, when you calculate that by putting here, if you will put the value of 76 centimeter here, if you put the value of density as 13.6 into 10 to the power minus 10 to the power 3 and G value as 10, what is the value that you expect as P atmosphere to come? That value will come out to be 1.01 into 10 to the power 5. Is it clear to everyone? This is the logic that I wanted to explain. Okay, good enough. We understand this. Nothing else, nothing new. Okay, okay. So sir, the point at height becomes point 2. The point at height. What does that mean? Which point? Point 2 is here only. Point 2 has pressure now because of mercury. This is the mercury pressure, and mercury pressure and atmospheric pressure are equal. The pressure due to mercury column is equal to atmospheric pressure because the 2 points which belong to the same layer must have the same pressure. Okay. Okay. Yes. So that is why P1 and P2. Okay. Points of same layer. Cool. Thank you, everyone. Now, very simple discussion about what is absolute pressure and what is gauge pressure. So what is absolute pressure? It is the total pressure at a given point, while the gauge pressure is only the pressure due to the liquid column. And I've already explained you this, but did not give you the name of these two things. So let me take you back again to those slides. Yes, taking you back to those slides. Have a look at this, guys. This pressure that we saw was only because of the liquid column, because the container was covered, right? This is called the gauge pressure. This is called the gauge pressure. Means without atmospheric pressure. Gauge pressure is without atmospheric pressure. Okay, and when you start considering atmospheric pressure also, what will you start calling it? You will start calling it absolute pressure or atmospheric pressure. बताइए. So can I say that atmospheric pressure is absolute pressure minus gauge pressure? If you take this here, we can say that atmospheric pressure is absolute minus gauge pressure. Fine. Yes. So we have already known it. We are just formally defining it as a name. So we already know this. You can see this. Gauge pressure is absolute minus atmospheric, or atmospheric pressure is P absolute minus P gauge, and P gauge I'll write as HOG. Okay, everyone. Liquid column pressure is gauge pressure. Liquid column plus atmospheric pressure is absolute pressure. Simple as that. Okay, let's see some example quickly on this. So in a standard barometer, now this is a very interesting example. Okay, and I'll share something from my personal album. I'll share a photograph very soon from my personal album related to this question. In standard barometer, and I'm going to answer that, can we use any other liquid than mercury in the barometer? So we know that in the standard barometer with mercury, the height of the mercury column to measure the atmospheric pressure comes out to be 76 centimeter, which is quite manageable. This is what is going to be 76 centimeter. This is going to be 76 centimeter. Okay, everyone. So if in the standard barometer, we have to calculate the height of the tube if instead of mercury we fill water. If instead of mercury we fill water to measure the atmospheric pressure, how much do you think will be the column of water required? Or to what height the water will be rising to measure the atmospheric pressure? Just have a look at the difference of the density. Okay. So I'll give you the idea here only. The atmospheric pressure, which is measured by the mercury column only, say is height H1 into density of mercury into G. This will be equal to height H2 in water into density of water into G. Okay, everyone is getting this? The same atmospheric pressure when measured in mercury's column, it's H1 rho Hg into G, and in water it is H2, different height, into density of water into G. So obviously G value gets cancelled, you see that? And if I get to the value of H2, which is the column height of water, it's going to be H1 density of mercury by density of water. And what do we have here? What is density of Hg by density of water? What do we call this thing? We only saw this today itself. It's called specific gravity. How much is that value? It's a ratio. How much is that value? Okay, so it is 76 centimeter in mercury multiplied by 13.6. Okay, and this is just the same ratio. So if you divide this by 100 to convert it into meters, okay, obviously 76 has to be divided with 100. So this value will come out to be 10.29 meters. Do you understand what's 10.29 meters? 10.29 meters. I'm close to 175 centimeters height. My height is 175 centimeters. You need 1,000 centimeters. 1,000 centimeters. How many of those barometers will you be able to make? And how much amount of water will be required for that barometer? Right, exactly. You will require at least 11 or 12 sudis to stand over each other in order to create that barometer. But is there any barometer which is based on this water? Is there any barometer? Where is it? This is that barometer, by the way. This tower that you see, guys, this has height more than 10 meters. And fortunately, I've seen this with my own eyes. Definitely not Amsterdam. These are the same things. This is in the, I think, world's #1 science and technology museum, which is there in Munich. Yes. On this river they have created this barometer. Yes. Okay. When did I go to Germany? Or yes, I after the session. Not now. Okay. Yes, I have been to Munich. Okay, everybody. So important thing is, because this is the height of the column that you require if you want to create barometer with water, you cannot have this barometer in each and every laboratory, because then you will require a separate laboratory altogether in a university, in a college, in a school, in order to have this barometer only, which can be done just on any of your, any simple study table. You can create a barometer with mercury. That's basically the difference. Okay, everybody? Cool. Okay, so similar concept will be used here, which is called as a manometer. Now this one is called a manometer, which does the same job. But your barometer measures the atmospheric pressure, manometer measures the gas pressure. So whatever is the gas which is filled here, it is trying to exert a pressure here, P gas. Okay, and you see that mercury is filled in this tube, but it is not having the same horizontal level. Or rather, let me put it this way, guys. Earlier, okay, when the tube had only atmospheric gases applying the pressure, the height of the mercury on the two sides of the tubes had the same value. Okay, this height was same. But now, if here you bring any other gas which has different pressure, so now if the atmospheric pressure is different than the pressure of the gas, the levels will be different, but the logic will remain the same. That the 2 points which belong to the same layer should have the same pressure. So point P and point C and point B, they belong to the same layer, so they must have the same pressure. So here you have atmospheric pressure acting, then you have mercury column ka pressure also acting. So this pressure total is equal to the gas pressure. Let's see how many of you are able to get this with this minimum information given to you. Giving you people 90 seconds to try, and the time starts in 3, 2, and 1. Try to find out the gas pressure, which is pressure on the right side of the tube will be equal to pressure on the left side of the tube. The value of the atmospheric pressure to be used is also given. You should already know this though, but you can use it from what is written here. Okay. Okay, that's okay, no problem, guys. I'll show you how it is done. So everybody, the pressure at point C will be equal to pressure at point B is already written here. So if pressure at point C is equal to pressure at point B, but at B, definitely H rho G is acting. But now this is not vacuum. Okay, this is not vacuum here. There is already atmospheric gases also above it. So absolute pressure will be also having the atmospheric pressure acting on it. Does this make sense to all of you? Had it been vacuum, then we would not use this value, right? But because there is no vacuum, there is further atmospheric gases pushing the liquid surface A. So that is why more pressure of atmosphere is being added. Okay, everyone? So because above A, there is atmosphere. So that's why you will have to apply the atmospheric pressure point also. Okay. So everyone, the density of mercury, 13.6 into 10 to the power 4, 10 to the power 3, I guess. Yeah, 10 to the power 3. Height is 0.12 into G value, that is 10. And atmospheric pressure used just as 10 to the power 5. Simplify this, you'll get the value as 1.17 into 10 to the power 5 pascals. Okay. The calculations are shown here also. So again, the idea is not to get into the calculations, but to write this properly. That's more important. Okay, everyone? If we make a water barometer, won't the water boil in vacuum and cause some vapor to form? Now that will cause the vacuum to be filled with vapor. I'm sure you are talking a lot of chemistry here. So I'm not the right person right now to answer it. So definitely the one barometer that you saw is a very old one and not accurate for sure. It's not going to be that accurate. Yeah, I understand that because of vacuum, the pressure difference, there will be temperature difference. Because of that, there will be possibilities of evaporation of water for sure. But if you will notice, or if you'll do some googling of it, it's called Deutsche Museum, you'll find out that it's a very old museum, a very old barometer, and definitely not a very accurate one. That is why the mercury barometers are more useful. Okay. Chalo, everybody, let's move on to the last topic for the day before we run out of time. And today, in the last topic, we'll be speaking and we'll be discussing about the horizontal force that is applied on the walls of the container. Okay. So say you have a container, maybe a cubicle one, on this inside which you have some liquid which is filled, having a density rho. The dimensions of this is given to us as h, a, and b. Okay, cuboidal it is, height is h, length is a, width is b. So as we know that if you will keep coming down in the fluid, the pressure of the fluid will increase. So absolutely at point 1 and at point 2, the value of the liquid pressure is different. In fact, if this is open to atmosphere, pressure at 1, or rather say if it is not open to atmosphere, only gauge pressure is the pressure acting, the liquid pressure. Pressure at 1 is 0 because no height, but pressure at 2 is going to be h rho g. So how do I know the value of the force which is acting on the container wall? Definitely as the pressure is increasing, the force is also increasing. So when we speak about the horizontal force which is applied on the container wall, we basically try to find out the average force which is applied on the container wall. Because the force at the top is 0, at the bottom it is maximum, so we find out the average value. And by looking at the diagram only, you understand that we are going to get into the calculus a bit. So maybe at some depth x, I consider a small elemental area whose length is b, but whose height is dx. So the area of the small gray zone that you see is going to be b into dx. Okay, everyone? What is happening here? It's like this remote control. So this is basically that strip that you see here. This is b, this is dx. Maybe the container wall is from here to here. So it's a small strip that I've considered. Okay, guys? So That's the area that we have written. So obviously, if the overall force which is applied on the container wall is F, the value of the pressure at the depth x is going to be x into rho into g. That's basically the pressure. And the small force which will be applied will be equal to P into dA. Pressure is force upon area, so force becomes pressure into area. So pressure value is x into rho into g. Area dA is B into dx. And that's what is written here also, by the way. Okay, everyone. Now we'll be just integrating it. For things which are constant will come out of integration. Things which are not constant will be integrated. Okay, so have a look. So x into rho into g into B into dx. Everything which was written there. We will obviously start from 0 and we'll go till h. When we move from top to bottom, we are assuming that the container is covered. We are only interested in talking about the fluid pressure creating the force. Okay, guys. So when you integrate this, I'll show you the integration part also. First of all, constants like rho and g and b will come out, and you'll only be integrating x into dx. So 1, 2, 3, 4 terms are there. 3 came out, 1 is inside, going from 0 to h. Okay. So rho into g into b, the integration of x to the power n dx, definite integration. So that's why I'll not write plus c, is x to the power n plus 1. Okay, upon n plus 1. So the value of n in the given integration is 1. So x to the power 1 plus 1 upon 1 plus 1. So that is x square by 2, going from 0 to h. So when you put that, it's going to be rho into g into b into h square by 2. Okay, everyone, that's the force which will be acting as an average force on this entire container wall. That's basically the force which is acting on this entire container wall. This one, obviously the pressure value will be different here because the area will be different. Okay, so the value of that strip area will be different here. So whichever surface you are trying to find out, you have to talk about that. Okay, so if you need basically the average pressure, all you need is the force on an average which is acting divided by that area. Okay, so what you actually need is the value of the average pressure. This symbol represents average. So force divided by that area. The area of this wall is nothing but height h multiplied by the length, that is b. So area becomes b into h. Divide this entire force by the area, that is b into h, and see what happens. Half rho b into h square by bh. B gets cancelled, h gets cancelled. Half rho gh. Half into rho into g h. Half h rho g is the value of the average pressure. Why is it interesting and why am I stressing upon it? Is because when we were talking about the entire container, everyone, just focus on this last slide. Okay, the pressure at the top was 0. The pressure at the bottom was h rho g, and the average pressure can be understood just for for remembering it. The value will come out to be half into h rho g, which is actually the average pressure. So this way you can actually remember it. Okay, why do I need this? Because if I know the value of average pressure, I just have to multiply this average pressure with the given wall ka area. I'll be able to calculate the value of the average force applied on that container wall. Means what? Say if I just take this to the next slide, okay, and say we speak about this container. Okay, and it has say height h, this is L, this is B, okay, or maybe this is B and this is L, and it is completely filled with the liquid. So if I want to say write down the area of, or if I want to define the walls as A, B, C, D, E, F, G, H, okay, so the average force on A, B, C, D can be found as average pressure into area of that wall. So what is average pressure? Half h rho g, h remains the same. Multiply that by the area of this wall, and that is equal to h into L, right, everyone? H into L is basically the value of the area. So the average force comes out to be h square, or rather say rho g L h square by 2. That's the force on ABCD wall. Okay, but say if I want to find out force average on say BDGF, this wall, BDGF, BDGFB. Okay, so that value will be equal to P average into the area. P average is still the same, half h rho g, but multiply that by the area. The area of this is going to be B into h. So that comes out to be rho into g into b into h square by 2. Are you guys getting it? Why it is helpful to remember the value of average pressure, or rather the expression of average pressure? Okay, will I be required to derive it? You will not be, but will I require it in solving questions at times? You will. Okay, cool, awesome. Pressure is not a scalar, the pressure is not a vector quantity. That's the pressure throughout the container. The pressure h, half h rho g is throughout the container at that the average pressure on any of the walls. Okay, cool, great, nice. Sure, let's see if you can solve this one before we wrap up. Pressure is scalar, yes. Okay, then if you understood what I was solving, you will be able to answer this one quickly. Force exerted by the liquid on the vertical wall, that means this wall. How much pressure do you think is exerted on this vertical wall? Hey, 1 minute, there are 2 vertical walls. Let me see which one they're talking about. There are 2 vertical walls, obviously. So, okay, this one. No, in the options there is nowhere B comes, so definitely they're talking about this wall only. There is no option which has B mentioned in it, so they're talking about this wall only. And I will be creating this as a quiz. Okay, everyone, and here we go. Giving you people 45 seconds, and the time starts in 3, 2, and 1. Last 5 seconds now. Nice. So the usual, as you were solving. So F will be equal to P average into the area. P average is half h rho g, whatever is the height, you will use that as h. So h is the height, and this area is h into L. So half rho g L h square. That's the answer. Okay, guys. So this brings us to the end of the introductory session of fluid mechanics. We learned about fluid pressure, the relative density. We understood that why liquid creates the pressure because of the external force which is applied on it. It tries to create the pressure. Okay. Secondly, we spoke about atmospheric pressure. We understood the difference between gauge pressure and absolute pressure. Gauge pressure is the liquid pressure, and atmospheric pressure plus gauge pressure becomes the absolute pressure, or the total pressure. And the last thing that we spoke about is the average force applied by the liquid on the container walls. Okay. Good. So everyone, let me show you the leaderboard. Good. Congratulations, everyone. Those who are here on the leaderboard and those who are even not on the leaderboard. If you tried these questions, if you understood the session today, congratulations to all of you. Okay. And yes, I know you guys will not. You will not leave the session without this. And one more. Okay. So everyone, this brings us to the end of the session. And those who want to stay back can stay back. Those who want to exit now can exit. And class teachers, once you're also done answering all your doubts, you can also exit the session. Okay, everyone, switching on the chat now. Is that liquid pressure dependent on the reference? If you need to say by the observer, no. Okay. Germany trip was actually exactly 4 years back. Okay. Okay, Anshu sir, Germany trip. In fact, that was a Euro trip. It was exactly 4 years back in this week only, in the month of October, in this week only, and it was not an internship. It was on my birthday 4 years back. I had like decent amount of money accumulated for which I could have gone. How many days it was a? I guess it was a 12 days trip. 2017. I went. We started from Munich. We went to Prague. Then we came back to Germany again in Berlin. No. Sorry. We went to Munich. We went to Prague. We went to Poland. Then we went to Berlin. Then we went to Amsterdam. Year after that, 2018, we went to Paris, France. We obviously, me and my wife. Sir, पैसा बोलता है. बताने की जरूरत है. Sir, have you gone? Sir, have you gone to what? Sir, have you gone to any other foreign trip? I've been to Nepal, if that counts. I've been to Thailand, if that counts. Sir, before teaching, which job did you do? I was for around 7-8 months into Steel Authority of India. That is SAIL. Never been to Singapore. Never been to any other country. Yeah. These are the only countries that I've been to. So doubt in force exerted on the wall. Yes. चलो अब क्योंकि आज पहले हम लोगों ने नॉन अकेडमिक शुरू कर दिया तो yes. 2/1. Yes. We'll go to that. Yes. Tell me. How what? dx. This one now. Say if on the entire bottle the force which is exerted on one of the portions of it is 100 newtons. Okay. Can I say that on a very small imaginary portion of it, the force will be definitely much smaller than 100 newtons? That is small force df. The force which we can say is a very small amount of force. We can assume that on point P and on point Q, the force value is almost the same. That force is considered to be df. This is the general approach of integration that I did here only. The area of this small portion is B into dx. Do you understand this? Do you understand the value of pressure at a depth x will be x rho g? Multiplication of pressure into area is force. That is df. Okay. Because the entire area is capital A and this is a very small area, that's why we define it to be dA. Okay, Vihan. Raman, wait for some time. I'll unmute you. First, I'll take the doubts from this session. Yes, Aman. Good evening, बच्चा. बोलो. I'm good, as always. 62 पास है हमसे. बोलो. तो हमने इससे पहले इस वॉल पे प्रेशर फोर्स का वैल्यू निकाला था. वो एवरेज फोर्स आ गया. अगर एवरेज फोर्स को मैं इस वॉल के एरिया से डिवाइड कर दूंगा तो प्रेशर मिल जाएगा. वही एवरेज प्रेशर कहलाना चाहिए क्योंकि मुझे तो पता है कि टॉप पे प्रेशर 0 है, बॉटम पे प्रेशर और भी ज्यादा है. तो एवरेज फोर्स डिवाइडेड बाय द टोटल एरिया शुड बी लॉजिकली एवरेज प्रेशर होंगे, राइट? तो ये क्या लिखा हुआ है? दिस इज एक्चुअली फोर्स डिवाइडेड बाय एरिया. बस. तो उस वॉल का एरिया अगर ये हाइट h है और ये b है तो एरिया क्या हो गया? b into h. डिवाइड कर दिया. दैट्स इट. दैट्स इट. आज तो इंट्रोडक्टरी है तो आज को ज्यादा लोड नहीं है. चैप्टर भी इजी है, ओवरऑल फ्लूइड्स भी बहुत इजी टॉपिक है. ओके, गुड नाइट. ओके. अंतरिक्ष, द लिक्विड प्रेशर इज कॉल्ड गेज प्रेशर. वेट अ मिनट. पूर्व अंतरिक्ष कहाँ गया? ये the pressure which is created only by the liquid is what we call as the gauge pressure. Okay, Harshan, you'll have to wait. Non-academic doubts I take later on. Yes, Apurva. None of the questions you are able to solve from advanced exercise so far. Some of the questions you find difficult, right? That's absolutely fine. No problem at all. And it happens. I would say out of 100 questions of advanced, just an example, out of 100% questions, if I'm able to get 30 or 35 or 40% questions, I should still be hopeful. That's fine. I can come back to these maybe in the second round of revision, and then you can try those. No need to worry much. Okay. Okay. Okay, Harshita. See you tomorrow. Yes, Amalpita. Good evening, bacha. Awesome as always. Just tell me. that answer will come in either tomorrow's session or in the next session, most likely in the next session, when we speak about something called as Archimedes principle. The reason behind it is something which we call as buoyancy. Do you know how to swim? When we go in water, our body feels lighter because liquid throws us upward. That force is what we call as the buoyancy force. And the actual question, it is framed in this way, that a large, huge ship made up of iron can float while a small needle cannot float. It's basically because of buoyancy, and buoyancy depends upon the shape of the body also, and how the liquid has been displaced by the body which is going in the water or in the liquid. So tomorrow, when we will be having this discussion, I'll give you a lot of explanation of this. We will find it out. Mathematically, we'll find it out. By collapse, it means it shrinks. So just before this, we studied elasticity. Plastic bottle ka elasticity is lesser in comparison to glass, and they both have lesser elasticity than this bottle, which is made of steel. So even if this is filled with nothing, this is not going to shrink that easily because it has more strength, it has more elasticity. So that goes to the material property after that. But if I compare three different bottles which are having the same elasticity, they will result in the same situation when you create a vacuum inside. So it actually goes to the materialistic property elasticity, with the now that you are taking it into. Okay. So glass bottle, if created more pressure, it will crack. It may crack. In fact, it can. I would rather put it that it may crack. Depends upon the quality of the glass. Most likely it will not, but maybe if you create more pressure, I don't know, maybe in some of the weird movies it might have happened that maybe, imagine a movie in which a completely closed car goes inside the water and that keeps on sinking down and down and down and down. Then the glass also breaks off the windows. It's basically because inside the pressure is less, outside the pressure is more. So that outside pressure of water basically wants to crack the glass and water wants to come inside. Similar kind of situation can be expected from the atmospheric gases. If the glass is not of very good quality, then it may break. And with respect to plastic bottle, it's very well demonstrated that if you suck out all the air, it will simply collapse. If you missed the previous class, you need to watch that elasticity session. You understand what I'm talking about. Yes, Samadita. But the friction force acts tangential to the surface. The friction force acts, but the pressure is exerted by the normal force only. So that's why that friction will not create any pressure, even if it is there. Okay. Friction will not be able to create any pressure because it will always act tangential to the surface. Okay. Okay. Good night. Bye bye. Yes, Arshan. Don't ask me. I'm solving all the questions, but I'm not able to get certain questions. Don't ask me. I'm not able to manage studies at school. And Vedantu, don't ask me what should be the perfect timetable. Apart from this, if you have any non-academic doubt, please ask. More than that. What kind of a question is that? What kind of a question is that? First of all, I do not know how you are doing in your tests at Vedantu. Have you been regular with all the tests? Tell me your last three scores out of, or last three JEE main test scores out of 300. Out of 300? That's a pretty good performance. That is why they suggest revision, and I will not repeat the 3-star method today. That is my personal favorite method of revision, and obviously we are human beings, we tend to forget, so we have to revise every time. Okay. Absolutely, that is why not all the animals will be able to have the similar quality in deserts as camel. Maybe if you take, say, a cow, the cow will not be able to walk as easily as camel could. So definitely nature has a big role to play, and that is why camel is a desert animal. Yeah, absolutely. Okay. Hang in there, yeah. Just don't take too much of this. Alright, that's the best thing to do. Telling you from my experience, when I was preparing for JEE, I only first solved for the entire year my coaching classes material only. If you will be able to complete that, and then you will be able to solve it one more time, and then one more time, you don't actually require much additional content because we will provide that additional content also. Don't have to worry. That's why I personally do not recommend or do not vouch for any other book. More than enough. Trust me, it's more than enough at the stage which you guys are in. Stick to one book. I said this earlier also. Stick to one book. Solve it at least 3 times in your JEE prep, comparatively solving 3 books only once. And if it is tougher, it is even better. Okay. I will have it. Thank you. Okay. Bye bye. Raman, your microphone is not working, bacha. By Apurva. Sir, in the candle experiment, you told there will be accumulation of vacuum. No, sir. But when the candle lit, then CO2 is there. No, still. Exactly, that's what I said. No, Nihal. It will be not vacuum. It will be more of carbon dioxide, different composition. That is more of a demonstration of why the liquid rises up, because there is different composition of the gas inside the glass and outside the glass. That is why. Okay. Hi, Sudeep. Hello. Yes, Sudeep, you're audible. Bolo. Bolo. Because it's fluid. हाइड्रोलिक वर्ड कम्स फ्रॉम फ्लूइड ना, दैट्स व्हाई। तो तुम्हें याद होगा हमने उसे प्रेशर ही डिफाइन किया था जब हमने बात की थी, क्योंकि वो सॉलिड्स हैं। The other two stresses were defined for solids, and the bulk stress was defined mostly with, or rather it is mostly used for liquids or gases. और liquids और gases में उसी टर्म, उसी क्वांटिटी को हम प्रेशर बोलते हैं, जिसे सॉलिड्स में स्ट्रेस बोलते हैं। शेयर स्ट्रेन, हाँ। हम्म। जैसे जब हम घर में, मैं समझ गया, घर में कभी रोटी बनते हुए देखा है? तो जब रोटी बनाने के लिए मम्मी उसको पहले उस पे रखती हैं, वो जो आई डोंट नो क्या बोलते हैं उसको, गोल वाली उस पे प्लेटफॉर्म पे रखती हैं। तो तवे पे नहीं यार, उसको पहले बेला जाता है। तो जब वो प्लेटफॉर्म पे रखती हैं, तो जो डो होता है, आटा जो होता है, वो थिक ज्यादा होता है और उसका डायमीटर कम होता है। डायमीटर कम होता है, जस्ट थिंग। हाँ, ऐसा कुछ है, मान लो ये मोटा ज्यादा होता है और ये एरिया कम होता है। तो जब हम इसके ऊपर टेंजेंशियल फोर्स लगाना शुरू करते हैं, तो ये कम होता जाता है और ये बढ़ता जाता है। तो ये जो चेंज आ रहा है, दैट इज बेसिकली बिकॉज ऑफ द शियर स्ट्रेस। गेटिंग? ये वाला साइड कम हो रहा है और ये वाला साइड फैल रहा है। चेंज तो हर बार ही नहीं है, तो 2D चेंज ही, पर ओवरऑल जो चेंज है उसको हम कैसे देखते हैं? हम ये देखते हैं कि ऊपर की जो सरफेस है वो कितना डिस्प्लेस हो गई कंपैरेटिव टू इट्स अर्लियर पोजीशन। ओके, एंड विद रिस्पेक्ट टू द वर्टिकल डायमेंशन टू दैट, ये वाला सरफेस हॉरिजॉन्टल, ये वाला सरफेस वर्टिकल। तो इसके कंपैरिजन में ये कितना इधर पहुंच गया, ऐसा सोच सकते हो। पहले यहाँ था, अब कितना इधर आ गया, ये जो भी था ये कितना इधर चला गया, वैसा सोच सकते हो। यदि ओरिजिनल लेट सकते हैं उसका, ओरिजिनल हाइट का पॉइंट ऑफ व्यू। हम एक्चुअली उसको डिफाइन कर रहे हैं, मतलब उसका और बेहतर विजुअलाइजेशन है। एक कार्टन बॉक्स इमेजिन करो। ओके, एक कार्टन बॉक्स इमेजिन करते हैं उस, एक मिनट शायद से मैं कुछ दिखा पाऊँ इस पे। ओके, तो ये कुछ ऐसा एक शेप में दिखाई दे रहा है। दिस इज परफेक्टली स्क्वायर राइट नाउ एंड इट्स अ थ्री डायमेंशनल ऑब्जेक्ट। अगर मैं इस पे ऐसे टेंजेंशियल फोर्स लगाता हूं तो इसका शेप थोड़ा सा चेंज होता हुआ दिखाई दे रहा है। तो स्ट्रेस का काम है शेप में चेंजेस लाना। तो और जब हम शियर स्ट्रेन डिफाइन करते हैं, तो हम बोलते हैं कि ये वाली सरफेस कितना डिस्प्लेस हुई, टॉप सरफेस जिस पे हमने टेंजेंशियल फोर्स लगाया, वो कितना डिस्प्लेस हुई। ओके, और ये वाली जो सरफेस है वो कितना आगे गई, वो उसके प्रोपोर्शनेटली आगे जाने वाली है, बोल सकता हूं। तो वी कैन एक्चुअली टॉक विद रिस्पेक्ट टू दिस सरफेस हाउ मच द एंगल बाय व्हिच दिस हैज गॉट बेंट। दैट इज व्हाई हाइट छोड़ो, मैं बात कर रहा हूं इस लेंथ की। ये जो लेंथ में दिख रही है, इफ यू लुक एट इट, इसको अगर एज अ सेंटर ट्रीट करो इस कॉर्नर को, तो ये उसका रेडियस की तरह ट्रीट होना चाहिए, दिस लेंथ। तो ये एक्चुअली एक छोटे से एंगल से डिस्प्लेस हो गई है। तो ये जो लेंथ है, अब ऑब्वियसली ये पूरा ऑब्जेक्ट नीचे आ गया तो हाइट तो कम हो रही है, पर इफ यू स्टार्ट फोकसिंग ऑन दिस लाइन, रादर इस लाइन पे फोकस करो, तो ये लाइन तो एक रेडियस की तरह बेंड हो गई ना। तो ये कितना बेंड हुई, दैट इज व्हाट वी ट्राई टू कैलकुलेट एज द शियर स्ट्रेन। ओके, हां वो सेम रहता है। ठीक है, रुक जाओ थोड़ी देर, बाकियों के डाउट्स भी अपन ले लेते हैं, फिर बात करते हैं। ठीक है, यस, ओके। सुधीर, यस विहान, गुड इवनिंग बच्चा, यस एज ऑलवेज ऑसम, टेल मी। आई नो। हम्म, 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 हम्म। स्कूल में, स्कूल में और जूनियर कॉलेज में? अच्छा, अच्छा, ठीक है, ओके, ठीक है। मैथमेटिक्स की बात कर रहे हैं ना अभी भी? इन वेदांत यू आर टॉकिंग अबाउट? अच्छा, ओके, ओके। हम्म, हम्म। कर तो सकते हो। हाँ, वो थोड़ा सॉर्टेड सा सोल्यूशन लग रहा है एक्चुअली। अगर वो करते हो तो कम से कम फिर ये तो होगा कि क्या, तो फिजिक्स में मेरे क्वेश्चन एडिशनली लगा लेना ना, उसमें क्या है? ये मुझे नहीं बताओ, ऑपरेशनली वो तुम्हें अपने सैम के थ्रू बात करनी पड़ेगी। हाँ, दूसरी चीज, अगर तुम्हें लगता है कि फिजिक्स और केमिस्ट्री तुम मैनेज कर पा रहे हो इस बैच में भी, और मैथ्स में थोड़ी डिफिकल्टी आ रही है, तो व्हाई डोंट यू पिक द चैप्टर्स एंड गो विद देयर माइक्रो कोर्सेज इंस्टेड। यू ऑलवेज वॉच द रिकैप्स ना, रिप्लेस देख सकते हो माइक्रो कोर्सेज के। तुम्हें बेसिकली जितना मैं समझ पा रहा हूं, तुम्हें थोड़ा सा ट्यूनिंग विद द टीचिंग स्टाइल में शायद से डिफिकल्टी आ रही है विद मैथमेटिक्स। नहीं, मैं वही बोला कि टीचिंग स्टाइल का डिफरेंस है। See, subject is same, different teachers teach. Some students get, accustomed, or they find some teachers' explanation more easy to understand. While the same thing explained by someone else might not be as good understand. अगर मेरा खुद का एक्सप्लेन किया हुआ कॉन्सेप्ट शायद तुम्हें अच्छे से समझ में आता हो, किसी XYZ को उतना अच्छे से समझ में ना आता हो, ये हो सकता है ना? तो अगर दोनों ही स्टूडेंट मेरे रिकैप, जिसको नहीं समझ में आ रहा है वो मेरे सेशन के रिकैप देखेगा तो कुछ बदलने वाला नहीं है। बट अगर मान लो वो किसी और टीचर के रिप्लेस देखता है, तो शायद उसके लिए वो ज्यादा हेल्प हो सकता है। समझे? ठीक है, तो इसलिए मैंने तुम्हें दोनों दोनों तरीके मैंने बोल दिए कि अगर तुम बैच चेंज करते हो और ये चेक कर लो कि भाई फिजिक्स के सेशन तुम्हें डिजिटली यहाँ पे अटेंड कर सकते हो क्या, वो जाता है तो आई वुड आल्सो रिकमेंड चेंजिंग दैट बैच। वो नहीं होता है तो फिर मैं वो माइक्रो कोर्स वाला सजेशन दूंगा। एंड थर्डली, आई विल आल्सो आस्क यू टू स्पीक टू शिमोन सर आल्सो। ही इज योर मैथ्स टीचर, राइट? स्पीक टू शिमोन सर वंस, लाइक यू आर स्पीकिंग टू हिम। मेजॉरिटी वाली बात नहीं है, जस्ट टू अंडरस्टैंड कि हाउ शुड यू अप्रोच मैथमेटिक्स फ्रॉम हियर। Getting how should you approach mathematics from here is something that the subject matter expert can actually tell you better. Like I can tell you if somebody has a similar situation with physics, I can say that just manage till this chapter. From here, we will enter into a new unit which will have nothing to do with mechanics. So then you can actually put it on hold, focus on the currently ongoing chapter, and then as and when you find time, you can always do the recaps of the previous chapters. So with subject, what is going on in mathematics is something that your maths teacher can only tell you. And how should you approach it from here? Right now, at this moment where you're standing from here, how should you manage your backlogs? How should you go forward? Can you skip a few chapters? Can you put them on hold? ये सारी चीजें तुम्हें मैथ्स के टीचर ही बता सकेंगे बेहतर, है ना? Again, something which should be done with proper guidance of your teacher. Okay? एक बार तो बात करना बनता है ना? सेशन will end in 5 minutes, ऐसा आया मैसेज, ठीक है। तुम लोगों को भी आया, आई थिंक दैट सेशन एक्सटेंशन मेरी वजह से आज के लोगों ने टाइम को हाफ एन आवर एक्सटेंड कर दिया। चलो, आई थिंक यू टॉक अबाउट इट एंड वी कैन स्पीक नेक्स्ट टाइम वंस अगेन, लेट अदर्स आल्सो स्पीक। ओके, टेक केयर। ओके, या बाय बाय। फॉर्मेलिटीज में नहीं जाते, जल्दी जल्दी बात करते हैं। यस रमन, जल्दी बोलो, रैपिड फायर। हाँ हाँ, वो क्या करे? रॉड मास्टर्स है, और कितना कोई वेट है जो रॉड से नीचे हैंग कर रहा है, और मुझे सर्कल कंप्लीट कराना है। हाँ, 2 फुट क्लियर होगा, क्योंकि इस केस में थ्रेड वाली सिचुएशन नहीं है, तो इवन इफ रॉड वर्टिकल पे चली गई तो ये मास्टर यहाँ पे है, पहले यहाँ था, अब यहाँ चला जाएगा, गिरेगा थोड़ी। जीरो कंसिडर कर लिया, तो rather they are just considering at zero, मतलब बोल रहे हैं कि 0.01 सेंटीमीटर पर सेकंड भी होगी तो भी आगे आ जाएगा। टेंडिंग टू जीरो कंसिडर होता है, जीरो कंसिडर नहीं होता है। तो उसको कैलकुलेशन के लिए जीरो ले लेते हैं, बट प्रैक्टिकली उससे जरा सी वेलोसिटी अगर रही टॉप मोस्ट पॉइंट पे तो भी बॉडी आगे आ जाएगी। दैट्स द लॉजिक। समझ में आया कि वहां ऊपर जाके जीरो क्यों ले रहे हैं, अंडर रूट आरजी क्यों नहीं ले रहे हैं? क्योंकि हमने जब डिराइव किया था तो स्ट्रिंग अज्यूम करते हुए डिराइव किया था, और स्ट्रिंग के केस में बॉडी अगर ऊपर गई और बॉडी की वेलोसिटी अंडर रूट 2 आरजी से कम हुई तो बॉडी पहले गिर जाएगी, क्योंकि स्प्रिंग है। लेकिन रॉड गिर नहीं देगी उस मास को, तो टॉप मोस्ट पॉइंट पे जस्ट टेंडिंग टू जीरो वेलोसिटी है, तो मैथमेटिकल कैलकुलेशन के लिए उसे जीरो ले लेते हैं, तो आंसर अंडर रूट 2 आरजी आता है एट द बॉटम मोस्ट पॉइंट। ओके, ओके, that's okay, Nihal, no problem. Sir, from September 15, 24, I was having school exams, so I lagged a lot in Vedantu, both in solving and revising. So now my practice is not going with class. What to do? I have started preparing for upcoming test labs of Vedantu only. It is correct, or should I go for any other method? Tests are kept so that you do the revision, so that you do not lag much behind. Always, in case of lags, follow the test syllabus. That's more important. Always remember that. Sadik, you're going in the right direction. Okay. Sir, I'm able to solve only 45 to 50 questions in test out of 90 in the given 3 hours. How do I improve my speed? When you are solving at home, you should always put a timer when you are studying. Say you start solving exercise, tattva exercise at 10:30. Okay, from 10:30 till 11:30, put the timer. Once the timer goes off 1 hour, calculate how many questions you solved. Every time, try to increase that number every time by say at least one more question. So in 1 hour, first 1 hour when you did this, you got 110 questions. Try to make it 11 in the next 1 hour. That's how you can actually keep a check of number of questions that you solve. Okay. Yes, Sudhir, quickly. जल्दी बोल दो, मैं सॉल्व शायद नहीं कर पाऊंगा क्योंकि बंद होने वाला सेशन। तुम क्वेश्चन बोल दो जल्दी। किस सिचुएशन में? सर्कुलर मोशन में, ट्रांसलेशनल या रोलिंग? रोलिंग ऑफ द टायर्स में अगर नेचुरल रोलिंग हो रही है, नेचुरल रोलिंग अगर होती है तो जो बॉटम मोस्ट पॉइंट होता है उसकी वेलोसिटी को जीरो रखना है। तो अगर सिर्फ रोटेशन देखो तो ये वाला जो पॉइंट है वो लेफ्ट में जाना चाहता है ना, और ये वाला पॉइंट अगर ट्रांसलेशन है उसकी वजह से आगे जाना चाहता है। तो दिस इज वी, दिस इज ओमेगा आर, तो वी से दैट वी शुड बी इक्वल टू ओमेगा आर। अगर मान लो हमने यहाँ एक फोर्स लगा दिया तो इसकी वजह से अब सेंटर ऑफ मास एक्सेलरेट करने लगेगा, लेकिन ये वाला फोर्स रोटेट तो नहीं कर सकता, क्योंकि रोटेट नहीं कर सकता बॉडी को, क्योंकि सेंटर पे लग रहा है, टॉप पे लगा सकता, तो बॉडी का एक्सेलरेशन तो बढ़ेगा, लेकिन ए इक्वल टू अल्फा आर